Okay, welcome back to Mr. B's math class. Today we're going to look at 5.3, the surface area of a prism. So our two outcomes for today, the first one is I can link area to surface area. So looking back at what we've learned about how to find area in past grades, like grades 5, 6, and 7, and linking that to what we're talking about today as surface area. And two, I can find the surface area of a right prism. So linking that to what we know about prisms from the last two lessons. So the first thing we're going to look at is the question, what is surface area? Well, pretty much simplified down, surface area is just the sum of all the areas of all the faces of an object. So adding up all the areas of the faces of an object. So just so we understand, if we had a cube here, that's not a great cube. If you were to add up, here's a face, here's a face, here's a face. On the other side of that cube, we got a face there, there, and of course the bottom. So we would add up all the areas of each of those faces, and that's how we get surface area. So it's one side, 2, 3, 4, 5, 6 sides added together to give us surface area. So let's take a look at our first example. So the first thing I'm going to ask you to do is just a review from last class. We've got a nice rectangular prism here, and again, not drawn wonderfully by me, but surprisingly, this is one of my better drawings. So you can see we've got our right rectangular prism here. I'd like you to draw the net of this prism and label it please with the proper units. So go ahead, you want to pause it now, you can draw your net and then hit play when you're ready to check it out. Okay, so let's take a look here. I'm just going to get rid of this. There we go. And now you got our net. This one isn't is even drawn worse than the other one, but you can see here, you get the idea. So I've got my 10 here, which was my length across. I've got 10 here, and 10 will actually be here, 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 here. It's consistent the whole way across. So 10 centimeters. My height was 6, so that's right here. And that would actually also apply, if we really wanted to, at here as well, and here as well. Because this piece here, when folded, it's got to be the same as this piece here. So we know that both this and that will be 6. And we've got our width, which was 4, and that's going to be this piece here, the flap that fold up the sides. So we've got now our net drawn. Now again, what is surface area? Well, just again to review from the first slide, it is the sum of all the areas of the faces of an object. So right now we're going to try to figure out the areas of each of these faces to figure out what our surface area is. So I've got to figure out the area of 1, 2, 3, 4, 5, 6 faces to get surface area. So where should we start? Well,
first things first,
nah, we're not the realists. First things first, we'll find the faces is what we're going to try to do here. So, thank you, Iggy. Now, when we've got our objects here, we got our 3D prism here in our net, we need to find the area of the different faces. Well, what's lucky for us is that we know right away that some faces are the same. But we'll get to that right away here. So we're going to look at our front, top, and our side views. So we can break this down like we looked at in 5.1 as our front view, our side view, and our top view. So we're going to find our faces. So if we look at the area of our front, that is right here. So we're going to figure out that one out. When we look at it, I'm just going to, for myself, draw it because it's a little bit easier this way. It's a rectangle, and as you can see right here, it is 6 by 10. So I'm just going to write that down for myself. 6 centimeters by 10 centimeters. Now I need to find the area of this face. So we'll take a look at this one first. So area, as we know, equals length times width. So area of this one is going to be our length and our width of this shape, which is going to be 10 centimeters times 6 centimeters. So the area of this face is going to be 60. And this again follows the idea of finding the area of the different faces, which was our front, side, and top view. We got that one taken care of. Now our side. Now we're taking a look at our side here. Well, when we look at our side, we know it's 4. And because we can assume it's the same on both sides, this is also going to be 6. And as you can see over here as well to the right, it's 4 and 6. So our side view, when I draw this out, is going to be 6 centimeters. Sorry, you can't read that very well. And 4 centimeters. Same thing as before. We find area by looking at length times width. Area equals, in this case, 6 centimeters times 4 centimeters, which gives us a grand total of 24 centimeters. Now, one thing to notice though, it should actually be centimeters squared because we are timesing a centimeter times a centimeter, which gives us centimeters squared, as we learned back in our unit on square roots. So that's my bad for forgetting that. And our top view here, which when we look at it at the top, we know right away it's 10, and it's 10 by, which is our width, is 4. So our top view looks like this, and it's 10 centimeters. And because it's that piece there, this side length should be the same as down there, which gives us 4 centimeters. So again, we know what area is length times width, and in this case it is 10 centimeters times 4 centimeters, which gives us a grand total of 40 centimeters squared. So now we're going to look at step 2 here. So in step 2 it says multiply the areas by 2. So first we had our front view, we had our side view, and we had our top view. Well, the front we knew was 60 centimeters squared. The side view we knew was 24 centimeters squared. And the top view was 40 centimeters squared. Now you might ask yourself, why are we multiplying it by 2? What's the deal with that? Well, the idea here is when we have, again, oops, this is not a great drawing. When we have our 3D object, there, in this case, we did look at, our front view, our side, and our top. But remember, there's the side here, and there's a side here. There's a top here, and a bottom here, a front here, and a back there. So there's 2 of the same side on this object. There were 6 sides. This is the same as that, side is the same as the other side, top and the bottom. So that's why we're multiplying by 2, because there's actually 2 sides to go with each of these. So when we look at our 6 centimeters, timesing it by 2, we're going to get 120 centimeters squared. For our sides, we have 2 of those. One side is 24. So again, we're going to multiply that by 2, and we're going to get 48 centimeters squared. And last but not least, the top. We got a top and a bottom. Multiply that by 2, and we're going to get 80 centimeters squared. Step 3 is just to add all the areas together. So then really all we have is, look at our front, we can drag this down here, and we have 120 centimeters squared plus 48 centimeters squared, that's a horrible 8, I'm sorry, and 80 centimeters squared, which gives us a grand total of 248 centimeters squared as our surface area. So let's take a look at our next 3D prism. Okay, so second one here, we're looking at the surface area of a right triangular prism. So just like before, I'd like you to draw the net of this prism. Okay, so just like in 5.2, give me a net of this object with the measurements, please. So you can pause it here and hit play when you want to check out the solution. Alright, so let's take a look here. If I could grab this, and we've got a really crudely drawn one of me again. I apologize, I'm not an artist. So again, you can see here when we unfolded the sides, they came into here as rectangles, and when the front and the back folded down, we're left with our triangles here. So let's take a look at the surface area now of this triangular prism. Okay, so step 1 here says, find the area of the faces of the object. Very similar to last time, but notice I'm not looking for our top and side, because this top and side view might be a tiny bit different, because now we got a triangular prism. We're not looking at something like the rectangular cube. So when I look at this, the faces I see are this side, and the bottom, right? When I look at it, they're all the same. They're all the rectangles on here that I've unfolded. And lucky for me, because the triangle here is an equilateral triangle, I've got 3 centimeters for this distance and 3 centimeters for that distance as well. So each of these rectangles in the middle is 3 by 9. So I'm going to draw that as my first face that I see. And it's 3 centimeters by 9 centimeters. So just like before, we have our area equals length times width for a rectangle. So in this case, it is 9 centimeters times 3 centimeters. Oops, not squared yet, which gives us a total of 27 centimeters squared. Now our next face we can see here, which is different, or shape I should say, is a triangle. And we can draw that here. And our base of our triangle is 3 centimeters. So, just like before, we're going to look for the area. And we know, just like from past years, to find the area of a triangle, we need to do our base times our height and divide it by 2. So in this case, our base times our height was 3 centimeters times 2.6 centimeters divided by 2, which when we do all the math there, it makes it 7.8 centimeters squared divided by 2, which gives us an area of 3.9 centimeters squared. Now I'm just going to keep this up here. Now step 2 then says multiply the area of the number of faces, of the same number of faces, sorry. So when we look at our picture, what it means is this rectangle here, how many of those were there on this triangle? Well, we know there's 1, 2, 3. So we're going to look at it and say, okay, we have 3 rectangles, which means that we're going to do our area of 27 centimeters squared and times it by 3, which gives us the area of all our rectangular faces, 81 centimeters squared. Then we're going to look over here, and we know that our triangle, our area of our triangle was 3.9 centimeters, and there's actually 2 triangles. So we're going to have our area equal 3.9 centimeters squared and multiply it by 2. Now, that gives us an area of 7.8 centimeters squared. Now our final step before, we are going to add the areas together to get our surface area. Well, we knew our area of our rectangles. We had an area of 81 centimeters squared, and our triangles, we had an area of 7.8 centimeters squared. So when we add that together, 81 centimeters squared plus 7.8 centimeters squared, we get a surface area of 88.8 centimeters squared. So that's how we found the surface area of a triangular prism. Now, one thing to keep in mind that I have down here is that to keep in mind that surface area is the sum of all the areas of all the faces of a 3D object. So again, when we looked at our 3D object, okay, it is the areas of this piece, this piece, this piece, that inside piece, that back piece, and that bottom, all added together. So in this case, it was 6 areas all added together. Okay, so keep that in mind when we're looking at our assignments tomorrow.